Hello, everybody, and it's your boy Joe coming at you from under the sea. Don't be too distracted by my beautiful background. Today we'll be finding out how to find an inflection point on a graph. So, what is an inflection point? An inflection point is where the graph goes from being concave down to being concave up, and vice versa. So, it's not exactly the min or the max, but we'll find out how to get that as well. Um, Let me move the video up in this corner. So this presentation has kind of three parts: how to find the x-intercept, how to find the min-max, and how to find the inflection point. So in order for us to find the x-intercept, we just have to make the function equal to 0 and solve for x. So let's say we're given a function where f of x is equal to x cubed plus 4x squared minus 12x. If we make it equal to 0, I started by factoring out the x. So we know one of the points is equal to 0. And then if we solve for x squared plus 4x minus 12 and make that equal to 0, all we have to do is find 2 points that give us negative 12 and 2 points that multiply to give us negative 12 and that add to give us 4. So the 2 points were negative 6 and 2. And there's our x-intercept. If we graph this function, I graphed it using Desmos, you can see that that's exactly where the intercepts are. Now, the second point is how to find the minimum and the maximum. And the minimum and maximum is this point right here and this point right here. So in order to find the minimum and maximum, we just have to take the second derivative of the function, or the first derivative of the function, sorry, and make that equal to 0. So the derivative of our original function would be 3x squared plus 8x minus 12. And in order, so if we take that and make it equal to 0 and solve for x, we get something like this. We can't use the x method or the crisscross method. So we'll have to use the quadratic formula. Yeah, ignore my camera. There's just no good place to put it. So I'll put it right in this corner. Anyway, from here, we can see that the 2 points that I got here are 1.07 and negative 3.74. So we know that those points are where our minimum and maximums are, but we don't know which is which. So we'll talk about that in a bit. One way to find out which is which is to just plug those points into the original function, not the first derivative, the original function, and get the y values. And then whichever one gives you the higher y value, you'll know that that's the maximum. So if we plug the 1.07 into the original function, we get that y is equal to negative 7.04. And if we plug the second x value into the first function, we get that y is equal to 48.57. So we know that this is going to be a maximum. Another way to find out which is the maximum and the minimum is to just plug the x values into the second derivative. So if we plug them into the second derivative and we get an answer that's less than 0, then we know it's a maximum, which means the graph will be facing down, concave down. And if we get an answer that's more than 0, we know that it's going to be a minimum and the graph will be concave up. Now, if we plug the x value into the second derivative and we get an answer that's equal to 0, then we know it's an inflection point. So we'll be using the second derivative to find the inflection point. You just have to make it equal to 0. That's it. So this was our original function. This was our first derivative. And this will be our second derivative, is 6x plus 8. So if we make that equal to 0, we can see that we'll end up with x is equal to -4/3. And to find the y value of that, again, we plug it into the original function. And we get that the answer is the y value of our inflection point is 20.74. And again, if we graph the original function, we can see that that's exactly it. Is -4/3 and 20.74735. Not too bad. And that's it. So again, the inflection point is, for example, if you're finding, if you want to find out, if you're using calculus to calculate the slope of how downhill your life is going, the inflection point is essentially where things start to turn around for you. So I thought that was a pretty cool concept. Anyway, thank you for watching, and stay blessed.